In this lecture, we trace the curve x whole times of x square plus y square, which is equal to a times of x square minus y square. We have to trace the curve x into x square plus y square equal to a times of x square minus y square. Let us just simplify it. So x into x square is x cube, then plus xy square, which is equal to ax square minus ay square. Now we can take y square, we have to take this to this side. So x plus a and y square is common, and we can take this to this side. X square we can take common and a minus x, and which gives us y square is equal to x square into a minus x whole divided by x plus a. Let us give it equation number 1. Now we check the following points to trace the above curve. The first point is symmetry. Since the power of y is even, so the curve is symmetric about x-axis. Now if we see the whole equation, so power of y is only even. If we see this term, just look here. Power of x is 3 over here, power of x is 1 over here, power of x is 2 over here, power of y is 2 over here. So in each and every term, y has even power, therefore the curve is symmetric about x-axis. Now, since the power of x is not even, it is 3 and it is 1 over here, so this curve is not symmetric about y-axis. Similarly, since the power of x is not symmetric is not also since the power of x is also odd, therefore it is also not symmetric about both the axes. If you want to check the fourth symmetry, which is about opposite quadrant. So if we replace x by minus x, the equation of this curve will change. So it is also not symmetric about opposite quadrant. If we replace x by y or y by x, then also the equation of the curve will change. So it is not symmetric about line y equal to x. And similarly, we can easily prove that it is also not symmetric about line y equal to minus 1, line y equal to minus x. Hence, the given curve is only symmetric about x-axis. The second point is origin. Since in the whole equation, there is no any absolute constant present over here. Just look here, each and every terms have variable. Therefore, the curve passes through origin. Now the second question arises, if the curve passes through origin, then what is the tangent at origin? So tangent at origin is given by lowest degree term equal to 0. So if we see the whole equation, what is the lowest degree term? It is nothing but what is the degree of this term? Degree of this term is 3. Degree of this term is 1 plus 2 is also 3. Now here a is constant, so degree of this term is 2 and this term is also 2. So we have the lowest degree term is this. So we can write down a times of x square minus y square equal to 0, which gives us, because a cannot be equal to 0, since a cannot be equal to 0, therefore x square minus y square, which is equal to 0. So if we replace x square to the right hand side, we have y square equal to x square, y square is equal to x square. And if we take the square root of both the sides, so what is the value of y? Y is equal to nothing but plus minus x, or y equal to x, and y equal to minus x. So at origin, there are two tangents. One is y equal to x and another is y equal to minus x. So we have two different tangents at origin. If we want to trace this one, so this is the y-axis, this is the x-axis, and this is the tangent y equal to x. This is the tangent y equal to x, and this is the tangent y equal to minus x. This is y equal to minus x. So these are two tangents at origin. Now, since at origin we are getting two different tangents, therefore the nature of origin is node. Since there are two different tangents at origin, therefore origin is node. Let us try to find out what is the intersection with coordinate axis. From equation number 1, we have x square, x times of x square plus y square, which is equal to a times of x square minus y square. If you put y equal to 0 over here, if you put y equal to 0, y equal to 0 over here, this y equal to 0. So we are getting x cube, which is equal to ax square. What we are getting? X cube equal to ax square. So x square, we can write down, this can be written as x cube minus ax square, which is equal to 0, which gives us x square, x minus a equal to 0, which is equal to x equal to 0 and x minus a equal to 0, which gives us x equal to 0 and x equal to a. Similarly, if we put x equal to 0 here, this total term will become 0, this will become 0, so we have y equal to 0. So put x equal to 0 in 1, we get y equal to 0. Hence, curve meets coordinate axis at 0, 0 and a 0. Means this is the one point 0, 0, and this is another point a 0 where curve meets the coordinate axis. Now let us come to the next point, asymptotes. What is asymptotes? Asymptotes is a straight line which is finite distance from the given curve but touches at infinity. So now let us try to find out the asymptotes parallel to x-axis. So here the highest power of x is x cube and whose coefficient is 1, so which cannot be equal to 0, hence no asymptotes parallel to x-axis. Similarly, parallel to y-axis, here the highest power of y is 2 and whose coefficient is x plus a. Now just look here, if we simplify it, x cube plus xy square, which is equal to ax square minus ay square. So if we, this is the highest power of y square, so we are getting x plus a times of y square. So we can take the coefficient of y square is equal to 0. So x plus a equal to 0 is the asymptotes parallel to y-axis. And since there is a parallel asymptote, so there is no oblique asymptotes of this curve. So what is the parallel asymptotes here? Let me tell you how to draw this parallel asymptotes. This is x-axis, this is y-axis, and this is x minus x equal to minus a. So this will be the asymptotes parallel to y-axis. Okay. Now, what is the reason of absence? From equation number 1, we have y square is equal to x square into a minus x upon x plus a. So what is the value of y? Y is equal to x. If we take the root, so x square is x, root over a minus x upon root over a plus x. Now, if x is less than minus a, means what it means? If a minus x is less than 0, a minus x is less than 0, or we can say that a is less than x or x is greater than a, and also a plus x is less than 0, it means that x is less than minus a. So if x is greater than a, x is greater than a, then the value of root over x plus a will be imaginary, means negative, and root of negative number is imaginary. So ultimately y will be imaginary. Similarly, if a minus a x is less than minus a, then also y is imaginary. So it means that there is a no part of the curve for which x is greater than a and x is less than minus a. What it means? It means that the curve lying between x equal to minus a to x equal to plus a. That this is the reason, and the remaining part, there is no part of the given curve. So let us try to trace this curve. Again, since the curve passes through the origin and no branches of the curve exist to the right side of x equal to a, so there exists a loop between 0, 0 and a0. This is very important point. So let me just trace the curve, then it will be very clear how to trace the curve. The first thing is this is x equal to x equal to y equal to x is the first tangent at origin. This is y equal to minus x is the second tangent at origin. There is we are getting 2 point. This is 0, 0, and this is a0, a0. And now we have already seen that there is a no part of the curve which is x equal to minus a, which is less than x equal to minus a, and which is also greater than x is equal to a. So this is the part where the curve will not exist. This 2, 1. And now this y x is equal to minus a is asymptotes. X equal to minus a is asymptotes. So the curve, let me again try to draw the curve. How to draw the curve? Now, since there are 2 point, it is 0, 0, and it is a0. So in between that, and this is the line. So this is what it is, the closed part. So the curve will lie in between this three curve, 1, 2, and 3. Now this is the tangent. This is also tangent. So we have like this curve, this type. Okay, and again, if there is a closed loop, so again this line will be again tangent at this point. So we are getting closed loop over here. And now this is tangent, and obviously it is also tangent. So now this curve will go like this. Similarly, this curve, this branch of the curve will also go like this. And since this is asymptotes of the given curve, so this branch will never cut the this line x equal to minus a. Hence, this is the approximate shape of the given curve. Thank you.